Good evening, sir. Hello. Good evening, sir.
गुड इवनिंग गौतम, कैसे हैं आप?
अच्छे हैं सर। आप कैसे हैं सर?
मैं ठीक हूँ, बिल्कुल फाइन।
Good evening, all participants. So today is the session 7. So today our expert speaker is Gagandip sir, who is the founder and director of Rosie Computech Services, Kurukshetra. So sir, take his second session today. So please sir, you can start your session.
थैंक्स गौतम, लेट्स स्टार्ट। Good evening, everyone.
Good evening, sir.
Today is very insightful discussion on explainable AI. I think you heard about XAI. Basically, in this era, in this artificial intelligence, deep learning, machine learning era, we are building systems that can see, decide, and even create what you want. Fine. But along with this power, we also need trust. I will give you one example at the time while I discussing. Okay, while I am using ChatGPT, and everyone seen many times, okay, that need trust means verification every time. And it's not enough for AI to just give the right answer. We must understand why it gives that answer. That's why in today's session, we will have a very insightful discussion on explainable AI, especially in the field of computer vision. You can use explainable AI everywhere. But today we are talking about computer vision. We are discussing about deep learning. Our FDP is based on deep learning. That's why we are exploring XAI on computer vision. To explore how we can make our AI models more transparent, reliable, and responsive. Let's start. This is the simple line, making AI decisions understandable to humans. Yes. Sometimes we are not sure. Sometimes artificial intelligence says, okay, this is a dog when we showing a picture of cat. For that, explainable AI refers to method and techniques in artificial intelligence, especially machine learning and deep learning, that make the decision and predictions of AI models understandable to humans. When we use AI models like deep learning, they make decisions using thousands or millions of parameters, which human can't easily interpret. A simple example we are taking here. We are giving marks to our students, like we just check their exam, and we gave them marks. We know that now, okay, how we gave that marks. But now, with the artificial intelligence system, which evaluating the examination paper, if some artificial intelligence model gave 40, 50, 60 marks in evaluation, then how you can trust that these marks are genuine marks? There is the need of explainable AI. Because explainable AI says, like us, why these marks are, or why these marks are because you had not attempted 2 or 3 questions. Why that marks are your process is incomplete. You had not completed the process. Your result is fine, but your process is wrong. That is the way explainable AI is doing. We can also take an example of deep learning model. Says this image is a dog. Yesterday, in no code Google Teachable Machine, we saw that at some time I was fallen, but that was saying, okay, I'm not fallen. But sometimes I'm sitting there, but says fallen. That is a depend upon. But how did it reach that conclusion? How did? That means XAI help us visualize or explain why the model made that decision. Just like this, XAI allow us to see why the AI gave us certain answer. In short, we can say AI that explains its thinking process, means making AI decision understandable to humans. Now, what exactly need explaining an XAI? AI model, especially deep learning models like CNN or transformer, take inputs, for example, an image, and give output, for example, cat or dog. The challenge is, how did that model arrive at that output? Which part of the input mattered most? Is it recognizing correctly or just memorizing patterns? Imagine you have this question, how did the model arrive at that output? Which part of the input mattered most? Is it reasoning correctly or just memorizing that? Imagine you have a black box, says a magic camera, like this. You have a black box. This AI model is a black box. And this is representing by a magic camera. And it sees a photo, or it takes a photo and says, this is a cat. Now you ask, why do you think it is a cat? If the camera AI model can show or tell you what part of the photo made it think cat, that's explainability. If it can't, just guessing, and we can't trust it blindly. So explainable AI means making AI decisions understandable to human to build trust, debug errors, and find biases. That is 3 things: trust, errors, and biases. That is the main concept of explainable AI. I think all of you understand what explainable AI is. Fine. Now, we will move towards why is this important? AI model, especially we are talking about deep learning models because we are in the session of FDP, deep learning in computer vision. Deep learning models like neural networks used in computer vision are often considered black box, which I told in previous slide. They can give highly accurate predictions, for example, classifying images, or but we don't always know why or how they made a certain decision. Like in medical, a model detects cancer in an X-ray ray image. Fine. But can the doctor trust it if they don't understand why it flagged the image as cancerous? And sometimes in AI system, now your loan processing is also at some places they are using artificial intelligence. So AI system denies a loan based on a photo and other inputs. Can the decision be explained in human terms? That's where XAI comes in. Why is XAI important in computer vision? Just I told you, okay, whether that image is cancerous, whether that is that loan is denied, why that loan is denied. That is the concept of computer vision. That it gives, when we build a model that detects like a tiger in a photo, in my example, they may be detected and explained with a good reason. Like good reason, it looks at the strips and phase patterns of the tiger. And bad reason, yesterday we saw that the bad reason. Okay, when I am just showing the images, my hand comes in and background is also there, my wall. And with my hand and wall, that detecting something else. That is the bad reason. Means it says that this is tiger because it only looks at the grass in the background because all tiger photos were taken in the jungle. But without XAI, we would not know what the model is focusing on. With XAI, we can see its attention and fix the biases. Real life analogy we are taking here, like someone says, okay, as I said in my first slide, okay, someone gives you the answer of any mathematical question. How you can check, okay, how he or she reached at that result? Then we have to see na, okay, how he or she worked in their rough work instead of the final answer. That is this type of the way we can come to XAI. Now, there are a 4 pillars of explainability. In XAI, explainability is there, and XAI method can be classified based on what and how they explain. One is scope based, another one is mechanistic or mechanism, and another one is representation or exploration based. Fine. In scope based, basically every mechanistic or representation based explanation type is either local or global. Local means microscopic view. We are seeing a particular image, yani one decision at a time. And global telescopic view, the whole model reasoning. How we do that in general? These both are defining the scope of the explanation, is the local or global. Mechanistic, that is internal logic, how that is performing internally, their neuron activities, their layer behaviors different, because we are working in CNN, then there are different layers and what their behavior is. And representation based is what the explanation look like how input data is encoded or transformed in a latent space. That is what the explanation look like. You can see here local versus global explanation, local explanation or global explanation. Another one is mechanism based explanation or representation based. I will explain all these in 3 or 4 slides. Now, local and global explanations, the scope of the explanations. Local explanation are like case studies. You zoom in to understand one particular decision. Like GradCam. What GradCam is? GradCam is a method, technique to show the results, to process that, show which part of the image activated, the neuron responsible for the class level. For instance, the model looked at the whisker region. Whisker means that is some heat map where different colors are there to decide it's a dog or not. Simply explains one prediction at a time. We can say, why did the model says this image is a dog, this, and you explain why you gave 8 marks on question 3. You can say, because the student wrote the correct formula but missed the unit. Or why do you think this photo has a dog, cat, tiger, etc.? That is a local scope. Fine. Whereas global explanation looks at the model's personality, not one decision, but its pattern of decisions. For example, the model relies most of the lung opacity and texture contrast for diagnosing pneumonia. It helps us ensure the model is learning medically relevant features, not shortcuts. We can say the model is overall logic, but kind of pattern does the model use to identify dog in general? How you generally graded papers? Give full marks for correct steps, whether that is in a 2-line or a 4-line, and partial cutting for minor calculation errors, and 0 for wrong concept. This is how did you usually identify? How did you find? How do you usually identify dog, cat, tiger, etc., whatever is? That is a global scope. Fine. And I showed here GradCam, line, shape. I will talk just later on with the 7 to 8 slides. After that, we will work on GradCam, line, or shape. These are the Python libraries you can use here. These are the methods, these are the techniques we use here for different. And now, mechanism and representation based explanation. That is, mechanism explanation is inside the model brain, how explanation is generated. You can ask what kind of pattern each neuron detects, like edges, texture, or object part. For example, one CNN filter activates for wheels, another for animal eyes. These concepts deep learning to cognitive understanding. Whereas representation-based model, how the model clusters and separate inputs and internal spaces. I will show you in after 2 or 3 slides, okay, how we can make representation based. With the example, you will see. For example, a dog image may lies near foreleg, fur, snort, fine. All things that will show you the concept. Now, you are seeing here, okay, output of mechanistic explanation is interpretation or neuron filters, and output of representation or exploration based explanation is visualization of abstract feature spaces. Because I said you, at human level, the representation based explanations are represented. That's why that was represented. That's why we are saying that these are. There are different models, different techniques, whether that is a feature importance technique, different method, saliency map, surrogate methods, counterfactual method, textual explanations. I will show you in, I think after that will come. Mapping with 2 dimensions, that is mechanism, and output form, what means representation based. In mechanism, how gradient based model is there, technique is there, perturbation based is, concept based is, example based is, and similarly of saliency map, whether that is feature importance, textual explanation, or representative, and for with which we can execute that. The based method. The main examples of question XAI helps answer. Why did the model label when it flags anomalies in surveillance? Now let us explain some of them with the feature importance. Like this shows features. Which features? Like pixels, edges, part of images mattered most in the decision. How a doctor find out? By taking this X-ray, you have a TB, you have a cancer, or you have something. How? Because there are patches, and these patches will show you, like here in red highlighted region, influence the tumor detected prediction. Once my auntie ji get affected by TB, but initially doctor said that is a cancer. When they took a liquid and just diagnosed in lab, they found it cancer. But doctor says, TB doctor says, that is not a cancer, that is a TB. Because the color of the liquid is different from cancer. If that is a red or blue, that will be cancer. If that is a pale, that means that is a TB. So similarly, there is a tumor detected, and it will shows that is a pneumonia, that is a cancer, that is a TB, and at what part, at what area that is diagnosed depends upon that. Next one is saliency map, which I am talking about. And we will take the example of cat. That will give you visual heat maps that highlight the area in an image that the model focused on. For example, bright red spot on a cat face in an image shows this is why it is said cat. Surrogate rule graph. Surrogate rule graph is the same thing as decision trees. Why? The petal length is less, greater, or rule if this is then this, otherwise this. Fine. These are the simple interpretable model like decision tree. Why a prediction was made, that will show by a neural net. That is explained by decision tree. Next one is uh, counterfactual, shows how a slight change in the input would have changed the prediction. Like I said you, okay, that is TB, cancer, pneumonia. That depends upon the dark patches. Where that flag, okay, that is a pneumonia, that is a cancer, that is a TB, that is. According to this, next one is the textual explanation. Textual explanation, natural language justification of the decision. For example, this is a dog because it has four legs, fur, and a snout. That depends upon. And according to that, it identifies it is a dog. Fine. Which type of dog? That is golden retriever or other dog. It based on the processes, the definitions, the CNN trained model, that depends upon them. Fine. And this is the process we can check. Now, there are two categories of XAI framework categories. One is model specific versus model agnostic. Model specific works only with a certain model type like CNN. But model agnostic can work with any model of your machine learning, your deep learning, any model. But model specific only work with CNN or some other models. After that is, there is framework is post hoc versus intrinsic. Post hoc explanation comes after the model is trained. Intrinsic model is designed to be interpretable from the start. For example, there is a decision tree. That is the concept of the framework categories. I am not going into the detail because I have to just introduce you all these things and also give you some example. Today, we will also work with some like we will use Gemini or ChatGPT also with this. Fine. To make a trust, to make a visibility, and goals and benefit. Trust lead us towards human AI collaboration. Yes, if there is a trust, we will get human AI collaboration. You know about ChatGPT. One time I wrote an article on ChatGPT. Just I will show you. I will show you ChatGPT. Is this visible? Google, rogics.com. I was asking ChatGPT what that model is, why that model is. Uh, yes, कैसे चैट जीपीटी हमें बेवकूफ बना सकता है, इंग्लिश में भी लिखा होगा आई थिंक. यस, हाउ चैट जीपीटी कैन मेक अस फूल. I was asking something, and when I asked, give me a today message, one day, I'm writing every day message. Nowadays, I broke up. Otherwise, last 9 months, 8 months, I did that. I was sending every day a message of good morning with a cyber security tip, with the what is on that day. Every time I asked ChatGPT, and I gave a framework to ChatGPT, and that will produce a message for me, and I will check and give the, and just message everyone, broadcast that message. Once I asked him, give me today's message, ChatGPT gave me 3 days back date. How? Every day he's doing fine. I just copied and pasted. Then my brother called me and said, today is that day. ChatGPT made me a beefcoof, fool. Then there is a need of verifiability. Means I have to verify every time. And that is the main reason behind that. You can read, और जब उसको बोलो ना कि यार तूने ये गलत किया, और the message is always, sorry, I apologize this, next time this won't happen. And after 3 or 4 days, always ChatGPT start doing that. One time I was writing an article on some topic, and I said ChatGPT, do this topic. Yes, I am preparing this, and when I prepare this, I will give you, and you can see. मैंने कहा अच्छा मैं इंतजार करूं? नहीं नहीं नहीं, नो नीड, आप सो जाओ. रात का टाइम था 11 बजे का, मैं सो गया, और वो मैं उससे 6 दिन मांगता रहा, उसने वो मेरे को नहीं दिया तैयार करके, तो वो हमेशा बेवकूफ बनाता रहा. तो that's why we need explainable AI. And yes, ChatGPT is doing best, but sometimes millions of processes are there, methods are there, layers are there, they are working, and some things make it a different way. Like you heard about an article, न्यूयॉर्क न्यूज़पेपर में एक आर्टिकल बना था. फाइन, न्यूयॉर्क, when in 21 that was introduced, someone is communicating with ChatGPT, and ChatGPT started flirting with that person. You can see New York Times, and you can read that article. That is a very good article. Starting for flirting. See a movie, She, 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 English movie. She is the operating system, and how that make fool on same pattern. ChatGPT start flirting with the person, with the news, basically a journalist who wrote the article, and you can see that due to these reasons, this type of explainability need we have need of the trust. We have need of the transparency. So we understand how the debugging to find and fix issues in the model. Fairness ensures is not in using discriminatory factors like just I told you flirting. That was a not fairness and ethics. Compliances, legal and ethical accountability. Yes, ChatGPT failed in starting. Given the formula of atom bomb, Parmanu bomb, every time. And after that, ethical or made stronger. And just when you even ask about cybersecurity, he will say, no, I can't give you this code because this is not in my terms. Sorry for that. Even nowadays, जब अभी ज्ञानेश गुप्ता जी ने कहा प्रीवेसी हर्ट हो जाएगी लोगों की, तो प्रीवेसी के लिए चैट जीपीटी भी जवाब देना शुरू हो गया है कि नहीं भाई, मैं मोदी जी की फोटो नहीं बना के दे सकता, मैं ट्रंप की फोटो नहीं बना के दे सकता. समटाइम इट गिव्स बट समटाइम इट स्टॉप्स. That is the behavior of ChatGPT or any artificial intelligence modules. And compliances, legal and ethical accountability, that is the health and insurance portability, HIPAA, whether that is the GDPR, General Data Protection Regulations. They come under this, and that's why. Improved design. Now, to help build better models by knowing what features matter most. Just wait, we are coming to our hands-on session. I think you have cleared all these things. If you have any doubt, you can ask. After that, we will go to hands-on session. If you have any question, you can ask me. Yes. Am I not audible? Hello, everyone. Hello, Gautam ji.
Hello, sir. Audible, sir.
Audible. Yeah. If you have any question, you can ask me, please. Now, after that, we will start hands-on session and we will work on that. And I will show you Colab. And you are also working on Colab. I think you used artificial intelligence there in Colab. Just give me answers, please. Had you used artificial intelligence prompts there in Colab or in Jupyter Notebook? Okay. XCI tools. We have Python libraries, low code or no code tools. There are low code and no code tools, but those tools are not perfect till now. And one tool is XAI .ai. That is giving a, जैसे हमने OpenAI के साथ काम शुरू किया था ना, when we started in 21 OpenAI, we have to just communicate कि yes, I want to use OpenAI. They put us in wait list. Similarly, XAI will put you in wait list. We have.
Sir, I can
Yes,
ask you a
yes,
question.
please. Any
Sir,
question,
kindly
please?
explain TSNE.
Yes.
TSNE. You told TSNE. TSNE. Sir, you told.
TSNE.
T distributed stochastic neighbor embedding.
I'm not basically I'm not understanding what you are saying. Just speaker मेरी साइड पे नहीं है. Yes, हाँ please. अब बोलिए. एक मिनट मैं इसका.
सर TSNE
Yes. कहाँ पे बोला मैंने?
सर अपने बताया था TSNE आपका रिप्रेजेंटेशन में था TSNE.
Okay. I think TCAV. This.
सर
Just wait.
सर डायमेंशनलिटी रिडक्शन. Dimensionality reduction. TSNE, T-distributed stochastic neighbor embedding.
Yes. These are the method. TSNE, UMAP. Yes, TSNE. These are the methods.
Sir, please.
Yeah, you want explanation?
Sir, please explain it.
Yeah, just wait for that. We will.
Yes, sir.
अब आज मैंने बोला ना हम चैट जीपीटी को भी यूज करेंगे, तो यस हम वहां पे जो ये इस तरह के क्वेश्चंस होंगे हम वहीं पे बात करेंगे, क्योंकि अगर मैं उसको टीएसएनई को एक्सप्लेन करना शुरू करूंगा तो वो पूरा का पूरा एक्सप्लेन करना पड़ेगा. आप देखिएगा कि वो एक मॉडल है, मैंने एक ही मॉडल एक्सप्लेन किया है, दैट इज अ ग्रेड कैम, नॉट मॉडल, दैट इज अ टेक्निक बेसिकली, and I used here grad cam, nothing else, even not just wait. There are different models: lime, shap, techniques, capped cam, grand cam, alice. Is similarly there is a method TSNE. I will discuss you that thing, but in this lime, shap, capped cam, I just only explain grad cam, because in this 1 hour class I can't use all the things. Fine. That's why just we
Okay,
will
sir.
use a prompt
Sir,
there.
TSNE, सर TSNE कहाँ यूज होता है, किस लिए यूज होता है, वो मुझे मतलब आप बता दीजिए सर.
मैं बता देता हूँ, अभी वेट कीजिए, मैं आपको अभी बताता हूँ टीएसएनई के बारे में और सारा का सारा उस चीज के बारे में. अभी है ना, अभी बताता हूँ. जस्ट एक मिनट हम ये काम कर. हाँ, ओके. हम XAI Python library, we are using XAI Python libraries, and Python libraries Lime, Shap, CapCam, GradCam, LE5, AICTE 360, Interpret Machine Learning. These are best for local explanation, global explanation, or glass box or black box explanation, deep learning versions. Model, any type of model, Lime or Shap use, but GradCam use CNN. I'm not using any other. I will show you example with GradCam, Lime, and SAR. What GradCam is? GradCam is basically gradient weighted class activation mapping. Is an explainability techniques for CNN that shows which region of an image most influenced. The model's prediction, it works by computing the gradient of the class code with respect to the feature maps in the last convolutional layer. These quadrients were averaged to get weights that represent the importance. I just told you that will show you a heat map on the dog face or heat map on the cat face. That will show you, or other your cancerous image, fine, or pneumonia image. That will explain with the different weights, and different heat map can be overlaid on the input images. to visually verify if the model focused on the correct area. And
sir,
yes, please.
सर हीट मैप क्या सर हीट मैप क्या कोरिलेशन डिफाइन करते हैं मतलब रिलेशन बिटवीन द वेरिएबल्स?
हीट मैप क्या करता है कि हीट मैप से ना जिन चीजों के लिए, फॉर एग्जांपल फर, लेग, उसका स्नॉट, उसके ईयर्स, ये सारी की सारी चीजें होती हैं जो डिफाइन करती हैं। अब हीट मैप क्या करेगा कि वहां पे हर चीज को फाइंड आउट करेगा और उन चीजों को डार्क कर देगा, मतलब वहां का कलर डार्क होगा जो कि उसको रिप्रेजेंट करेगा। फॉर एग्जाम्पल मैं एक सिंपल सा एग्जाम्पल लेता हूं, लाइक इन इंडस्ट्री यू आर मैन्युफैक्चरिंग प्लेट्स, स्ट्रेट प्लेट्स for some particular purpose, like that plates used in the automobile, fine, and they must be straight. अब क्या करेगा ग्रेडकैम, क्या करेगा, उन प्लेट्स को स्कैन करता रहेगा, जहां पे भी उन प्लेट्स में हल्का सा डेंट होगा, इफ देयर मे बी सम डेंट, सम स्क्रैच,
ओके सर,
हीट मैप उस एरिया को मार्क कर देगा, मींस दैट इज नॉट गुड सर, वो उसको रिजेक्ट कर देगा, फाइन, दैट इज द पर्पस ऑफ द हीट मैप। मींस
सर सर
हाँ बोलिए
सर,
यस प्लीज
सर, then what is the use of box plot?
What is the use of
box plot?
That is for different processes. Here we are not using box plots. In GradCam we are using heat maps.
Sir,
box plots are also for that purpose, but that in different method or different techniques. In GradCam we are using heat map highlighted important reasons. Like heat map is there.
Sir. Thank you, sir. Actually, I was a confusion.
You are a confusion.
I had a confusion.
Box plot and
now
heat
I am
map.
cleared about that.
Fine. Thank you. That is different techniques, and in different techniques we are using different methods to form our output. Fine. To highlight the important reasons, that is whether that is in box plot, heat map, और एक और वो होता है आपका एक और भी रहता है, ठीक है, मैं अभी आ जाएगा, वो भी मैंने कहीं ना कहीं लिखा होगा।
ओके सर, थैंक यू सर, you have cleared my concept. ओके सर, थैंक यू।
ओके, बॉक्स प्लॉट, वैसे बॉक्स प्लॉट को हम यूज करते हैं स्टैटिस्टिकल प्रोसेसेस में, क्वाड्रेंट्स के लिए, Q1, Q2, Q3 के लिए बॉक्स प्लॉट इस पर्पस के लिए यूज होता है, बट वो किसी ना किसी जगह पे हम उसको आर्टिफिशियल इंटेलिजेंस में भी यूज करते हैं। एक बात और ध्यान रखिएगा, बॉक्स प्लॉट्स आपके क्वाड्रेंट्स के लिए होते हैं ना, ये उसको क्या बोलते हैं, बॉक्स प्लॉट्स को एक और बोलते हैं Q1, Q2, Q3 एंड समथिंग, उसका एक नाम और होता है, मेरे को अभी ध्यान नहीं है, मैं भूल जाता हूँ चीजों को जल्दी से। फाइन, तो वो भी लाइक अभी मैं बात कर रहा हूँ रियल वर्ल्ड के केस में, एक XAI लेते हैं हम फॉर चेस्ट एक्सरे, उसके लिए हम मॉडल यूज करेंगे CNN ट्रेंड निमोनिया डिटेक्शन, और टूल यूज करेंगे ग्रैडकैम, एंड शैप और TCAB भी यूज करेंगे। फाइन, तो दैट इज द डिफरेंट थिंग्स। सिमिलरली एक्सप्लेनेशन, दिस इज अ डॉग, एक्सप्लेन व्हाई a CNN क्लासिफाई एन इमेज एज अ डॉग, तो हम उसके लिए भी ग्रैडकैम, शैप और लाइन को यूज करेंगे कि लोकल रीजन बेस्ड एक्सप्लेनेशन है। सॉरी, मैंने हिंदी में शुरू कर दिया, और आई थिंक कुछ लोगों को प्रॉब्लम हो रहा होगा. Let's build a short unified example showing how three popular XAI techniques, whether GradCam, SHAP, and Line, can explain a model prediction on a dog image. That is, we will use mobile net. Yesterday, we used mobile net in Google machine, teachable machine. There is a mobile net version 2, pre-trained on ImageNet. Fine. So on trained, I said mobile net 2. That is the form of ImageNet. Fine. That's why, because yesterday we used ImageNet. So no training is needed, and we will visualize all explanation in one simple notebook. GradCam focus on CNN. Just written here, simple things, global feature influence or line local region influence. I will go to this example, that collab, needed collab. Collab. Just, I took one example of, I made reconnect. I will show you. Okay, we are using here NumPy as NP, NumPy as NP. Just no need to explain. We will come to, I told you already, okay, we will come to ChatGPT and we will ask and build here, okay, how we can make this model which we wrote here. This for please build me real world XAI for chest X-ray with GradCam, SHAP, and TCAB. What we wrote and what he gave, just he is making an article on that. We are not, we don't want an article on that. We want a code. Then we just rephrase GradCam visual local, just given here, and cam pointing just अभी कंटिन्यू कर रहा है, तो शेप फीचर है. स्लो है थोड़ा सा. Just I want to show you something which will help you in day-to-day life. It is very slow. Okay. Write a code for collab. I will show you that example, but taking time. Here, I will make another new notebook. Actually, my system is crashed and this have a low memory. That's why I think it is taking time. Otherwise, I'm always using Jupyter Notebook, not Colab. This time I am using Colab. पता नहीं कहाँ बिजी हो गया. जैसे मैं यहाँ पे कुछ देता हूं, इसको हटा देता हूं और इसको 1 मिनट. फाइन. मैं इसको रन करता हूं. रन टाइम, रीस्टार्ट sessions and restart session. Yes. Now run this. It will work. In my existing code which I wrote here, that is with our JPG file which I took from some site, gave that URL here. Just I will show you. Okay, that was ran, and now just see here how you can work with Colab, Gemini, Colab artificial intelligence work. Just explain error. Say here, explain error. It will explain. Could you please tell me which cell produced the error? Explain error. अभी इसने भी नौटंकी करना शुरू किया. That is the issue of the artificial intelligence. And just wrote this and run this. It will work and give you the photograph of chest X-ray. But this type of issues are not there. When we say ke explain error, this Gemini will show you the error, why this error came, and I corrected this error. It will take an example, this URL here automatically by searching websites, and it put here and run your code. That is the process of the Gemini in Colab. If you are not using, then use that. Now, GradCam functions. Just see what GradCam will do. GradCam will do heat maps on different region that is highlighted. That is the local explanation. Okay, in this image, this part is according to colors. We understood. Okay, blue, light blue, dark patches. These are, for example, light blue, dark blue. That is the difference between this image, the location where we want to search or where we want to check. Fine. That is, after that, there is another shape background. मैं अभी कोई दूसरा भी लेता हूं, हो सकता है इस पूरे के पूरे प्रोसेस की वजह से ये स्लो हो रखा है, कनेक्टेड भी हूं या तो मैं उस वजह से भी हो सकता है. इन शेप, बेसिकली शेप क्या करेगा, एक्सप्लेन करेगा. पहले तो सारे के सारे इमेजेस को जनरेट करेगा, आफ्टर दैट आइडेंटिफाई करेगा कि कहाँ पे कौन से जो रीजन है उनको हम ये बता सकते हैं कि यहाँ पे ये इशू क्रिएट कर रहे हैं. ये भी एक तरह का हीट मैप जनरेट करेगा. अभी देखना, ये देखिए, दैट इज reasons, different reasons and shock values. This class 562, that there are different classes, 562, 520, and they are defined by the values. Okay, this index shows there is an error, there is an issue or not. According to that, clippings are made always be, and according to these 562, like I told you, I gave you one example, okay, how the plates manufactured by you are seamless. That will be given by the classes, prediction classes. Okay, this plate is from this class and this is this class. For example, 360 is the perfect class. Which plates are with class 360? That will be defect class. If there are some defects, that will be shown different classes there. Fine. I will show you. Okay, similarly, PCBA like demo concept. Here it will give the sensitivity score. Okay, white patches are there and white patches minus 2.9, that is relative to 0. According to that, visualization summary on this, okay, calculated actual score for visualization. That shape impact is negligible to 0. Now means approximate 0 or approximate concept influences. And similarly, there are GradCam 10 raised to power 1 or 10 raised to power 1.5. Fine. Now, just I will show you. Okay, please explain each cell working in detail with outputs. ये सारे के सारे सेल्स को पढ़ेगा और उन सभी सेल को पढ़ता हुआ ये हमें डिटेल में कंसेप्ट देगा. Certainly, let's go through each cell. Cell 1, install dependencies. हमने वहां पे सारे के सारे इंपोर्ट फंक्शंस किए. यही है ना numpy. तो इसने यही कहा कोड डिपेंडेंसीज इंस्टॉल किया या वहां पे हमने फंक्शंस को इंपोर्ट किया, लाइब्रेरीज को इंपोर्ट किया, मेथड्स को इंपोर्ट किया। आफ्टर दैट आउटपुट उसके सेल टिपिकली प्लेस प्रोड्यूस करेंगे, नो विजिबल आउटपुट्स। देन लोड प्री ट्रेन मॉडल एंड सैंपल्स। लोड प्री ट्रेन मॉडल, सबसे पहले लोड किया CNN मॉडल। Load pre-trained model, CNN model Keras application mobile net, that is the mobile net model that explained here. And this is a powerful convolutional network. CNN pre-trained a image net data set, a large collection of general purpose images. Fine. Means to load the weight learned from the image net and includes top few, means to include thousands image net categories. Fine. After that, load the pre-processed sample images. यहाँ पे सैंपल इमेज हमने यहाँ पे की, तो इसने इसमें इमेज बताया कि हमने कौन सी इमेज ली, उसको कितने बाय कितने का साइज दिया। 224 बाय 224 का साइज यहाँ पे दिया, देखिए ये 224 बाय 224 का। एंड आउटपुट में क्या किया उसने, डाउनलोड डाटा किया फ्रॉम शोइंग द डाउनलोडेड प्रोग्रेस एंड चेस्ट एक्सरे इनपुट दिया। तो इस तरह से आप ये सारी की सारी चीजें समझ सकते हैं। इवन इन कोलैब, इवन इन जुपिटर नोटबुक, एवरीवेयर इज द आर्टिफिशियल इंटेलिजेंस जो असिस्टेंस है वहां पे दोनों के दोनों फ्रेमवर्क्स में है, जहां पे भी आप इसको यूज करना चाहते हैं। फाइन। आफ्टर दैट उसने कहा, इसने यहीं तक किया एक्सप्लेन सेल 3, कंटिन्यू टू एक्सप्लेन सेल 3 ग्रेड कैम हीट मैप जनरेशन। तो अब जरा हम इसका हीट मैप जनरेशन भी देख लेते हैं, किसने किस तरह से क्या कहा, कौन से कलर्स दिए। सेल 3 ग्रेड कैम, कोड डिस्क्रिप्शन कंटिन्यू gradient tape and it uses TensorFlow gradient tape. Fine. Explain that. कोई एरर नहीं है हमारा यहाँ पे, तो कोई एरर ही नहीं है। तो ये इसने क्या कहा, एक्सप्लेन द एरर। एक्सप्लेन cell this one known as gradcam function. इतना टाइम नहीं लगाता है ये एक्चुअली, हो सकता है इंटरनेट के उसकी वजह से ये सारा टाइम लग रहा है। ग्रेड कैम पैरामीटर्स लिए, हाउ इट वर्क्स, क्रिएट अ ग्रेड मॉडल, और उसने नॉर्मलाइज किया, अप्लाई किया ग्रेड कैम को। आउटपुट बताओ, ग्रेड कैम एप्लीकेशन एंड विजुअलाइजेशन। फाइन। तो ये इसके विजुअलाइजेशन के बारे में भी बताएगा। मींस मैं इस पे ज्यादा देर नहीं लगाना चाहता, और ये इस तरह से आप इसकी सारी की सारी, मैं ये कोड आपके पास भेज दूंगा और आप इस कोड को अपने आप कीजिएगा। और जो मैं आपको कह रहा हूं, आई एम सेइंग टू यू के जस्ट यूज ChatGPT एंड क्रिएट अ कोड right here, and if errors came, just say to Gemini ke please explain these error. When you are saying the explain these error, that will say okay, वो explain करता है, and then ये कहता है कि मैं इसको ठीक कर देता हूं, क्या ठीक कर दूं, आप ओके कर दीजिएगा, वो उसको प्रोग्राम को रन कर देगा अपने आप, आपको बताएगा कि यहाँ पे एरर हैं और इस वजह से उन एरर्स को डिफाइन किया गया है। GradCam heat map local explanation showing your chest X-ray image with colored overlays, typically red and yellow areas, highlights the reasons that the mobile net considered most influential for its prediction of the scoring classes. Fine. That is The user warning about input structure mismatch is also painted here, which is discussed in general begin in this context. Fine. After that is TCV like डेमो. यहाँ पे जब इसको नेक्स्ट को कहोगे शेप सेल को विजुलाइज करेगा तो शेप सेल के बारे में बताएगा कि शेप की जो एक्सप्लेनेशन है उसकी जो ये बिल्कुल नेग्लिजिबल है और इस नेग्लिजिबल नहीं इसमें इमेजेस हैं 562 के बारे में बताएगा. कोई बात नहीं, आउटपुट ऑफ द शेप सेल देखते हैं. ये तो व्हाइट पैचेस टीसीवी में है, व्हाइट पैचेस आउटपुट trying to explain the shape cell. Okay. Sorry, just in okay, I will take care of. I will speak in English only. And sure, you can say directly to me even, okay, speak only in English. Actually, mother tongue is always be Hindi, and that's why we are speaking in Hindi. Otherwise, there is no problem. Similarly, there is the output message, shape explanation. See here something you will see that displaying shape output. I will show you. Yes, prediction class 562. This tells you the specific ImageNet class that the MobileNet V2 model predicted as the most likely for your chest X-ray image. That is, these indexes are different in different applications, and that's why you can use. Yes, someone want to say something? Okay. The shape image plot always gives you different colors. For example, color scale, typically red areas highlight pixels on the region of positively contribute, blue areas is negatively contribute. Fine. And natural transparent area regions with little to no color indicate pixels that had minimal influential on the predictions. That means here red, that means these are positive, and blue, where dark blue is there, that is negative. And we have to identify that pattern. That is the way you can understand. Even it explained you everything of this code, whatever is written here. Fine. K predicted classes, why you wrote this. This is a grad cam, shape, and line. These three classes, three libraries are just like a no-code tools, low-code tools. Simple, small. We have comments here. Just 3 or 4 lines are there, and we are processing that code only. Fine. That's why. Now we will see another example with the dog, or just I will take you that dog. Just I took a dog image. That dog is a golden retriever. I took there golden retriever.jpg, and when I am using this, predicting, downloading, Labrador retriever is there. That is not as a golden retriever. That is a Labrador retriever or golden retriever, whatever is. It will show you. I took this image from some images. I put here the URL of that image. That will predict something and will show you. We used here MobileNet V2 model, same, and using Keras, TF Keras. Yesterday I told you in Google Teachable Machine, that was TF Keras, and this will predicted. That is a Labrador Retriever, not Golden Retriever. Fine, and that is different Ridgeback. These are the predictions which was given by our this mobile net pre-trained model. Fine. Now we are using another GradCam, and we will generate here heat maps. That on Sonot there is a red area nearby. That is a blue area. In this knot will show you that is a dog. And after that, when you use this code with the line image, that line image will show you here line. Line is the method techniques which we are using here, or Python libraries. In previously I installed here line, pip install line. Fine, and that will show you the reasons where there the dog reasons are there, and that's why it will shape. It will tell you okay, what type of the example this is. Similarly, there are different, and you want explain, just explain every cell. Explain every cell of this notebook with outputs. Same way it will explain. Nothing to worry about. Fine. And so much of code is not be able to explain sometimes. That is Labrador Retriever, where I had written here Golden Retriever. Just see here. Golden Retriever, not Labrador Retriever, but it was saying this is a Labrador Retriever according to predefined pre-trained model, and also with the help of this shape it shows that it is a Labrador Retriever, and it explains cell 1, cell 2, cell 3. In here, cell 1, cell 2, cell 3 all are referred by numbers. Which number of that cell? X1, BCMVL, ZF, second cell is this, and third cell is this. And explain everything in detail, and you can read from here. I will download and send you this. Fine. Accept. Okay. Accepted. And this will be shown here. Fine. Now came back to our this presentation. Just your one example you want to ask. TSNE model. Please explain TSNE for XAI. TSNE, distributed stochastic neighbor embedding. These are all machine learning models are there, and we are using that for. I'm not talking about models today, because every model you can use, whether that is a vector, whether that is a decision tree, linear regression, कोई भी मॉडल आप यूज कर सकते हो इन सारे के सारे उसमें. तो इस वजह से मैं इन चीजों पे नहीं आ रहा. That is, and you can find out. उसने एक एग्जांपल भी बना दिया है भाई PyTorch और sklearn के साथ.
Excuse me, sir.
Yes, please.
Sir, what kind of
Who is
project? Dr. Deepika, sir.
Dr.
Am I audible?
Deepika? Yes, I am coming on that actually. That's why I'm going.
Sir,
Coming
what
to
kind
my
of
presentation.
projects we can make with the help of explainable AI? Means my students want to make some projects, so what can I guide them regarding that? Which kind of topics means they can?
Anything, any artificial intelligence output can be explanation. Any.
Yeah,
आपने कोई प्रोजेक्ट बनाया, फॉर एग्जांपल इवैल्यूएशन ऑफ एग्जामिनेशन, आप एक स्टूडेंट्स को प्रोजेक्ट दीजिए, क्योंकि हम यूनिवर्सिटी या एजुकेशन सिस्टम से हैं, कि उनको कहिए कि एक इवैल्यूएशन ऑफ एग्जामिनेशन पेपर का एक वो बनाओ, प्रोजेक्ट बनाओ. चैट जीपीटी से हेल्प लेना, आर्टिफिशियल इंटेलिजेंस से हेल्प लेना, सारी जगह से हेल्प लेके बनाओ. वो लोग बनाएंगे. अब आप उनको कहिए कि इस पे एक्सप्लेनेबिलिटी भी लगाओ. फाइन.
यस सर.
मैंने आपको बिल्कुल सिंपल है, आप ना अपने सराउंडिंग में देखो, हम जा तो कहीं पे भी सकते हैं. वी कैन मूव एनीवेयर. सॉरी, आई एम अगेन स्पीकिंग इन हिंदी. वी कैन मूव एनीवेयर in the world to make any type of projects. Fine. But we must see our nearby areas. For example, we are teachers. We want to make a project on attendance system. The artificial intelligence and surveillance को use करके we can make artificial intelligence for attendance system. Like in your room, there is a camera who is detecting the persons and recognizing the face recognition and give you the result. Okay, this one is present. But fine. Now, there is no need, because that is a face recognition. But if you want to make a explainable AI there, in classification you can use explainable AI. Face recognition, if you use a face recognition, then there is no need, because if face is recognized properly, then what is the need of explainable AI? But if you evaluating your examination, like you evaluated and that artificial intelligence chatbot or whatever is gave you the marks, had you tried to evaluate any question paper with ChatGPT? Deepika or all participants, had you tried any time you can evaluate your examination paper with ChatGPT?
No, sir. I have created the paper with ChatGPT, but not evaluated.
No need. Just scan full copy and paste there and say evaluate this and see the result. Really, you will surprised how ChatGPT can do this. Yes, ChatGPT can do any real world problem solution. And also, if you want to say, give me the code, how you evaluated. After evaluation, give me the code, how you evaluated. Or help me to process a model or make a model for this process. हेल्प करेगा. हिंदी में लिखो, इंग्लिश में लिखो, पंजाबी में लिखो, अपनी लैंग्वेज में लिखो, किसी में भी लिखो. Right there, and that will give the result. Really, if you want to evaluate, for example, you have a PDF or you have a research paper, like you want to use your research article. Just give links of 5 to 6 research papers and say, I want to write a research paper
लड्डू में गई
for
थी यार दादी
myself. Yeah. Yes, please.
देख
Yes, please. Who is writing? Who is speaking? Please. If anything to me, just speak. Okay. Just give the links and say, I want to write a research article on this topic. Topic का name दो, and that will give you the article as it is. If you want to say कि references भी बना के दो मेरे को पूरे उसके साथ references भी बना के देगा really. और ये मैंने जो सा just I spoke back के if you want to write if you want to see a New York article of flirting by ChatGPT with the journalist, just see. That is the article of January 22. ChatGPT can do anything. At that time, on that article, ChatGPT was ethically compliant. That's why nowadays he give tightly some answers.
Hello.
Fine. Hello. Yes.
Yeah. Good evening, sir.
Am I audible?
Yeah. This is,
Good
yeah.
evening.
Yes, sir.
Who is on the
Very good
screen?
evening. This is Dr. Bharti Kavade from Pune, Maharashtra.
Dr. Bharti, yes,
As you
please.
said, sir,
Yes.
ChatGPT will give the details regarding the research paper, whatever title you give and references and all the details. But what about the AI plagiarism then? Because if you are doing that way, so number of papers may be completed within fraction of minutes and number of hours. And what about the
Many
ethical
of
things as
the
well as
people, soon, yes, Bharti, please listen. Many of the people, many of the participants, many of the researchers writing paper this way. If you are saying AI plagiarism, just the rough paper is with you and change that. That will give you the proper paper. There is no plagiarism, AI plagiarism.
Because in terms of Turnitin is the software for plagiarism checking. So in that report, it is providing the similarity details as well as similarity report as well as the AI plagiarism.
No. If you want to write that paper, just the rough paper is with you. Now you have ideas and write according to your way, nothing else. Even if you want to say ChatGPT can write this way, that will. And if you want to ask explainable, explain everything, yes, that will. That is the explainable AI, no?
So you mean to will not include
Bharti,
the AI flag, so that AI flag will be zero?
No, AI flag will give you, but I'm saying just that if you are thinking there is a humanized way you can change there are different softwares that convert into humanized article, but that is not a artificial intelligence article. You can understand that is written by artificial intelligence, that is by humanized AI, but I am saying the rough paper is with you and you can change it with as you want. The basic idea is with you, and from different papers, links which you give the references, that will be, and say to ChatGPT that should not be flagged by plagiarism software. Say, ask. It will be. श्योर आप करके देखिएगा. We'll try.
Okay, sir. I have not tried anywhere, anytime, so that's why I was curious about it and I was having that query. Thank you so
Yes,
much.
yes, try that. I'm saying try that. If you give one of your paper to ChatGPT, he will understand how you write. Fine. ChatGPT will write according to as you write in your previous papers accordingly. Really. And also say him, these are the topics of ChatGPT basically is explainable AI, because I'm saying that everything will be explained, everything will be given the answer. और जब वो आर्टिकल लिखता है तो आप उसको कहिए, उसी ढंग से वो काम करेगा. आप करके देखिएगा प्लीज, और इवेल्युएट करके देखिएगा सब. जस्ट आई एम सेइंग टू ऑल ऑफ यू, evaluate one question paper. Evaluate one question paper with ChatGPT and tell him okay, how I am grading the this answer sheet, how I am evaluating. Just define their preferences, generality is there, that will evaluate accordingly to you. See in different way. And also make some ChatGPTs like with your name, with your one email ID, second email ID, third email ID, and evaluate in different ways on different logins. With different logins, you will get the different result, or maybe same result, depend upon. Just try. Artificial intelligence is working in that way. The Deepika, just your answer, see nearby and give the work to your students. Make a project on this explainable AI, that make a project on AI, then put XAI in this project.
Yes, sir, I'll try definitely.
Just we will complete our topics. I think time is over. XAI in medical imaging, you can use, like I just said, you pneumonia, brain tumor, lung nodules, and fetal abnormalities. किसी भी तरह की, whether that is CT, MRI, X-ray, और कहीं पे भी use हो सकता है, anywhere, ठीक है? And it will give you transparency, like MRI. Once I need an MRI, in that MRI, I have a number of images in that MRI. I can't understand, but maybe explainable AI will help me to understand this MRI. In this image, there is abnormalities. Fine. But I don't have that MRI. I will try sometime when I got some MRI. After that is autonomous vehicle. Yes. Object detection is there, decision making is there, sense understanding is there. For example, whether that is a car, pedestrian, road signs. I drove that Tesla in 29 May, June, July, August. I was there in US, and my brother bought a Tesla. That was first version, I think, and everywhere that is working fine. But on some donks, on red lights, that need my help. Means Tesla calls me, hi Gagan, please make your, sorry, please assist me with the steering wheel. Fine. So that was the case where autonomous vehicle can use artificial intelligence, and Tesla promised to the customers that these issues will be resolved by December 2019. Second version came in December 2019. And we are also seeing the explainable AI. For example, you are using virtual assistants. This Alexa, Siri, or your Google Home. Every people was using there. In 19, I was used Google Home and Alexa there. And I asked Alexa, क्या तुम हिंदी जानती हो? Yes, थोड़ा थोड़ा जानती हूँ. आपके साथ हूं तो सीख जाऊंगी. When I was there in July to August, आपके साथ मेरा मतलब I just astonished कि क्या this Alexa is hearing everything which I am speaking. Yes. They made a grammar, and December 2019, they introduced Hindi, Punjabi, every language, Tesla. And वो अब हिंदी भी इतना अच्छा बोलते हैं कि we ask Tesla, sorry, Alexa, कि उसको जस्ट क्या हो, मर जाओ तुम अलेक्सा. व्हाट सी विल से, शुभ शुभ बोलिए. मतलब हर तरह का उसका एक तरीका है. एक्सप्लेनेबल एआई, वो एक्सप्लेन करती है उसी चीज को जिस ढंग से उसको बात करना है. फाइन. That is the case of autonomous vehicle. And also I talked about that your virtual assistants. Common themes across application: medical imaging, facial recognitions, autonomous vehicle, or key XAI tools, GradCam, Line, SHAP, counterfactuals, saliency maps, surrogate models, everything you can use. ये मैंने अभी आप लोगों के लिए बनाया था कि ChatGPT in question, because there is a black box challenge that explainable AI tries to solve, bridging the gap between powerful predictions and human understanding. That is the way. And we already talked about very much about ChatGPT. Fine. And I also showed you my article on my my blog. Fine. You can read from there and find out what is the way and how it is working. That is the concept. And thank you, everyone. If you have any question, you can ask me.
Thank you, sir. So if any participant have any question, so participants can ask the questions to experts. Sir, I think there is no questions.
Okay.
So already participant asked already the questions.
Thank you. Thank you, everyone.
Thank
Now
you, sir.
your days.
Thank you, sir.
Thank you. Thank you.
So now we have with us our next speaker, Dr. Amit Dogor, sir. So sir will take session 8. Dr. Amit Dogor, sir, is a associate professor and HOD in the Department of Computer Science Engineering, National Institute of Technical Teachers Training and Research, Chandigarh. And sir will take the session on face and object detection using deep learning models. So
Thank you.
sir,
Thank you,
please,
sir.
you can start your session now.
Okay. Thank you, sir. Am I audible?
Yes, sir. Yes, sir. You're audible.
Okay, now I'm sharing my screen. Can you see my screen, sir?
Yes, sir. But yes, sir.
So, dear participants,
Google Colab.
yeah, just
Okay.
before that, I request everyone to join and they can do hands-on with me. So here I'm sharing the Google Classroom code you can see on the screen as well as in the chat box. I have pasted the code KQZG23Q4. So now what is there in this? When you join the Google Classroom, you will see there sir, kindly confirm, is it visible or shall I make it more zoom?
Sir, make it more zoom.
Okay. So when you see
Yes.
here, you will find there are 4 folders are there. One is image dataset, presentation, code, and own model. So for practice, kindly you download for the time being the code given here and some images. Either you can have your own images or this thing for practice. And later on, you can download the presentation and other things. So any participant has any query regarding this, you require only Gmail account. To join this Google Classroom, you require only Gmail account. So, sir, can you read my annotations also?
Yes, sir. Yes, sir.
Okay, thank you. Now I'm starting the session. So here I can see some few of the participants have joined. So no issue. So my agenda is today is on face and object detection with deep learning models. And we will see why only deep learning, when to use deep learning and when not to use the deep learning. That is also important. So like when you have the end devices, when you have only CPU, you don't have much computation. When you have light devices, we can say, or at end user, you should use the traditional models. I will demonstrate you and we will see the limitation also. So for deep learning, once it is trained, then it can be using or the edge devices or at the light mode devices or in the local devices or with CPU devices also. Only that for the training portion, we require the GPU. So in this agenda, we will see about that some traditional model, what are their limitations and why deep learning models. So with this, I am starting the presentation. So I believe some experiments you might have done with the OpenCV. So now when we talk on the computer vision, installing the OpenCV in, and for this experiment, we are going to use a Google Colab, or you can even download the later on Anaconda for your offline work. There are so many IDEs are available or VS Code, whatever you are comfortable. But for this demonstration, I'm going to use the Google Colab. And also in Google Colab, there are certain challenges are there that also we will discuss today. So first I will demonstrate you with face detection using cascade classifier, what are their limitations. And then we'll see some object, how to apply the cascade classifier on certain object like on traffic signal, on car, or how to get the cascade classifier, how to download the cascade classifier. Then we will do with the real-time object face detection, and in between we'll start with the deep learning model. So now when we talk on the computer vision, so it's just like a theory for building artificial systems that obtain information from the images. Now when we talk on the images, it could be from CCTV cameras or some kind of video sequence, or it can be medical images, or it could have the multidimensional data from the medical scanners. So what is the objective of computer vision is to make computer understand images and videos. And along with this, there are certain challenges are there. For example, Now this image is given to you. So there might be some question, what kind of scene is there? How far is the building? Where are particular object? Where are the car? How many cars are there? So I will show you one image today. And in that image, we will count how many persons are sitting there or standing there, or how many faces are there. So how to deal with those, that also we will cover. So when we compare the human vision versus computer vision, so computer understand in the form of numbers. These numbers are the intensity values or pixel values. So you can see these are the pixels. These are the pixel and these are the intensity values. So again, we have black and white image. Their pixel value will be either 0 or 1. 0 will represent the black color, 1 will represent the white color. We have the gray image. Now gray image are the matrix images or in the form of matrix, and color images are in the form of array. So what is the major difference between matrix and array? Matrix is always two-dimensional and array can be two-dimensional or more. So color images are normally in the three-dimensional. There are certain algorithms which work only with the matrix, not with the array. So because of that reason, those who have worked with the MATLAB or maybe Python libraries, so we need to convert 3D to 2D, like RGB to grayscale. So, and now when we talk on the grayscale, the values are, the pixel intensity values are represent the gray shade in between 0 to 255, where 255 represent the white color, 0 represent the black color. And in case of color images, we have 3 planes, and so one represent the red color, green and blue. So normally when you deal with the computer vision applications with MATLAB, Scilab or some other, it is in the form of RGB. But in OpenCV, it is in the BGR format. So we need to take care of this. This is the important concept here. So any participant has any doubt in between, they can write either on the chat or they can interrupt me anytime. So similarly, what computer sees, these are the numbers. So now computer vision is not so simple. There is a hard. Why? So for example, now when we are detecting car, so viewpoint variations are there. Now you can see from the front side, back side, or from these things. So this is the one challenge, viewpoint variation. So if we do the traditional feature engineering, so these are the challenges. But in deep learning, these challenges are being taken over automatically. Then another issue of the illumination. You can see the now too dark, too light in between. Then scaling is another issue. Then small car, big car, or small object and large object. These are the challenges that are there. Another challenge of the same person, here you can see, same person, and this is known as intra-class variation. Maybe person with specs, or maybe beard, or some change in the background, or maybe maybe this photo may be at the age of 20 years, this may be age of 40 years, age variation. So this is known as intra-class variation. This is another issue. Then there is an inter-class similarity. Now there are two persons, but they look like same. Like there, two ladies are there, but they look like same. So this is known as inter-class similarities. Then facial expression. Now you are going to recognize the face, but again, there are certain expressions are there. Illumination. Now different pose could be there. So these are the all challenges are there. Now you can see some same car. Now intra-class variation is there. Now I hope you understood what is the meaning of intra-class variation. Same, but some variation is there. Then motion could be there, occlusion. Now there are, I will show you some pictures, and some people only we are able to see their eyes only or little bit of head. So, and other person is standing in front of that person. So that is known as occlusion. Then you can see here background clutter. So this is another challenge is here. And where we can apply these computer vision application, object detection, face detection, using either traditional method or deep learning method in various fields. In CCTV camera, in health, like we want to find the brain tumor or some related to other health issues related to security, access, and for other purposes. So OpenCV, this presentation is available. So just I will be a bit fast and you can refer it later on. So OpenVision has already optimized 2,500 algorithms, and already the companies like Honda, Toyota, Sony, Yahoo, Microsoft, they are using this. So open source, it's open source, and it has an interface with many programming languages like Java, Python, C++, and the MATLAB. And platform independent, you can run on anything. How to install? So you can simple say OpenCV minus Python or OpenCV minus contribution minus Python, and simple import CV2. So these are the pixel values, range from 0 to 255, and intermediate value represent the shade of gray. So in case of if it's a gray, only one channel is there. If it's a RGB or BGR, so it will have the 3 channels. So its value will be height, width, and 3. So this represents that is a color image with 3 channels. And in case of grayscale, only one channel is there. So now we are representing the colors. So you can see how to represent the color. So like if it's RGB, like if you do the HTML coding, so if we are giving the values from in between 0 to 255 and no value to green and blue, then it is a red color. Similarly for the green, blue, and we can do the combination of these. If we give 0, 0, 0, then it will be black, 255, 255, 255, then it will be white, and we can do the combination of this. So this channel represents the red, green, and blue, but in OpenCV, this channel is in the BGR format. The BGR format. So how to read the image? There are 3 flags are there. We want to read as in the color image, we can pass, or -1, 0, and 1 are there, or it's optional flag is there. Simple, we can read the image and we can perform the certain OpenCV operations like image rotation, Gaussian blur, and why edges are important, like in face recognition also. So we have to see the face expression, and edge will give the intuition where is the change. For example, now this is the intensity values. You can see there is sudden intensity changes are there, the 12 to 90. So definitely there is a kind of edge, and it's almost smooth. So here you can see the edge in this way. Then again, almost same. Then again edge is there. So then again edge, and here suddenly from 10 to 82 there is an edge. So you can see the look for the neighborhood with strong magnitude of change. So like in this way you will find the edge in the face. So internally the algorithms work like that, and now you can see you can read and get these small operations. You can input, convert into binary, invert, and this. Now come to the main point that we are going to implement just now. So first we'll deal with the HAR cascade classifier and what will the limitations. So it is a machine learning based object detection method that make use of the HAR features. Now what are the HAR features? So these are the HAR features, and they are trained on a lot of positive and negative examples. So suppose we want to train only on face. We want to train only for cars. We want to train only for eyes. We want to train for particular object. So what we need to take? We need to take a lot of sample of cars and some negative example. That means which are not car. It could be any tree, drone, aeroplane, or any other object apart from the car. Similarly, and it is a tedious work. Then now there are so many HAR cascade classifiers are available. which you can download later on from this link on GitHub or GitHub. So you can see here for frontal face, full body, eyes, license plate detection, right eye detection, smile detection, and these cascade classifiers are available. So you need to download how to apply. So just after downloading, simple, now we have import the CV2, then as CV, then we simple apply the cascade classifier and we pass this file. Similarly, we want to pass the car file, we will simply apply. We will read the face or object, and then after reading, now if it required, we can convert into grayscale. And if algorithms does not support array operation, then only we need to convert into gray or array to matrix. Internally, it is array to matrix. But for these example, it supports the array images. That means color images directly. Also, we can apply on the color images. So we can input, we can convert into BGR to RGB, because CV by default read into OpenCV read into BGR format. And then we can detect, we can apply simple, and so there could be multiple images, a face in the image. For example, let's say this is one image with single face, so it will return only one face. Let's say there are 2 or 20 faces are there, so it will return 20 faces. So we'll run loop for those 20 times, and what it will return, the coordinate of that face, like here. Now if we see about the coordinates, so we will find the X value, we will get the Y value, so we'll get the coordinates here. So face starting and the width and height of that face, and for that face it will draw the rectangle. You can see here it will draw the rectangle. Inbuilt, we are passing the image, the starting point. Now how to find the rectangle, how to draw the rectangle on this face? So now I want to draw the rectangle over here. So let's say this is one image and I want to draw the rectangle here. So it will find the X and Y coordinate here. Now I know the width. So let's say width is 20 and height is again, let's say 15. So how to find these coordinates? So it will be X plus 20 and it will be Y plus 15. So the value will be X plus width and Y plus H. And these are the colors we want to apply on the rectangle. So what will the color of this rectangle? It will be RGB format, so it will be red. If I want to give blue color, so it will be 0, 0, because it is in the RGB format, rectangle color. So it will be blue. If I want to give the green color, it will be 0, 255, 0. And this is the thickness of the line. And then we can run this and we can get this kind of output. So we can apply on the face. And now what is the core idea of HAR cascade? So the core idea of HAR cascade is that it is useful for detect the object on which it is trained, maybe on car, vehicle, face, or eye. That is a limitation also. So that means the HAR cascade, which is, I'm writing in a short form, HAR cascade which is trained on car may not be applicable for face or vice versa. So that means if I have to identify 3 objects, one as a face, one as eye, another as a car or vehicle, so I need to get 3 HAR cascade files, separate HAR cascade files. So this is again one kind of limitation. So instead of using the raw pixel value, what it do? It detects the pattern of contrast, like you have seen in the picture, light and dark areas, known as HAR-like features. These features help us to identify the line, edges, and texture difference in the image. So now it do the integral image, how it works. what it do the computation of some of the pixel value in any rectangular area. So I will also demonstrate you how to compute the integral image in the coding, and that makes the algorithm fast. Suppose you are doing some kind of publication work, so you might be working with maybe medical image or some other image, and you want to reduce the computation. So there you can apply this idea. So you can apply this integral image idea, and again I will explain during the coding. Then you can apply your algorithms, and each now how it works. The algorithm uses multiple stages of classifiers. So each stage quickly rejects the non-object region and passes potentially to the next stage. So if we uh, see the process, so convert the input image to gray. This is again optional, that depend on the algorithm. And then extract the features. These are this is also known as feature engineering, and use the trained classifier and region pass all the stages as marked as detected objects. What are the advantages? That is fast and work in real time, requires only CPU. And it works best on frontal images, and it is sensitive to lighting and rotation. So what are the other limitations? Other limitations are there. If it's trained for example, on car, it may not be suitable to detect on face or different object. So it will not be applicable there. So that is another limitation. And now if we see about the analogy of understanding, so suppose we want to perform a security checkpoint. So stage 1 will perform a quick scan to reject the most areas. Like in airport when we go, so it's just like a first stage perform the quick scan, then later stage you perform the deeper checks to confirm the face or object. That saves the time and improves the speed. So in summary, HAR cascade use the simple contrast feature for object detection. Again, integral image make the computation efficient, and cascade of classifier ensure the fast and accurate detection. So now, before proceeding to the deep learning for face, that is the main topic of today, just I'm going to show you the images. So meanwhile, just you download some of the images. So now if we want to work, how many persons are there we want to detect using the HAR cascade classifier on this image, or on this image, or on this image. So you can see the images are very complex now. There is a text, and different age groups are there. They have different features. And then you can see one face, but covered. So we will see whether it will work there. And also now so many people are there. So in next, after showing you the demo on HAR cascade classifier, I will show you how to count how many people are there using the deep learning concept, which is not possible in HAR cascade classifier. So if manually we want to count, let's say I have broken into 4 portions. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, around 60 plus people are there. So all these images I have already shared. So you can try with the 1 or 2. And also we can see there are 2 children. So we will try, then we will see, we will direct on the car, and then we will see the limitations and proceed for the deep learning models. So up to here, any doubt, question, query? Okay, there is a question how to join with the classroom. Okay, I'm sharing the link again. You simple just download the code and run the code along with me. So here I am making it as a pin.
Sir, I have a question.
Yeah. Yes, please.
Can I ask?
Yes. Yes.
Sir, in the border area,
Right.
So I went to Rajasthan border area. This light was a high powerful light was there. So what
Okay.
happens? What happened to me? I was watching that some.
So in border area,
Can I speak?
Can other participants can help me to reframe the question? There might be bandwidth issue, I think, at your end. So on border area, you want to capture the image, right? Any participant can reframe the question? Or Mr. Gautam Pal? Can you reframe? Dr. Swaroop, I think you had that doubt. You can unmute your mic, sir. Your mic is mute.
Okay.
So those,
okay, sir.
yeah.
So,
Yes, please.
sir, in the border area, some movement is there in the dark lights.
Okay, some objects are in the dark light.
Dark lights.
In dark, okay.
It may be a person. It may be a person.
It may be person or it may be wild animal also.
And so with
Right.
some sophisticated what sir is some explicit matters, then there is objectionable matters. How to identify this object is a two-legged person or a four-legged animals or whatever it is in a dark area, in the border area.
Very, I appreciate your question. Very important, very relevant. And so, sir, for that we required first the cameras, which should be infrared, IR cameras, infrared cameras, so they can recognize the image. Once they capture the data, then we need to do some kind of pre-processing. Some kind of pre-processing.
One question I tell you,
Yes,
sir,
please.
I was using I was a good relation with an basic personnel. He's give me a machine gun with the infrared camera.
Right.
That can identify a person in the dark.
I'm giving you one picture here. I'm showing you one picture, and now it's an open question. So all of you just try to find out what is this image. Okay, already I've shared the images. So under these images, there is a one image. Okay, important image. So now I have opened this image. Can anyone can tell me what is this image?
Sir, I don't understand. Sir, this is the
Right,
image,
right.
the border is there.
Yes. Now let me show you how to do
Sir, the
this.
border is there.
Yes, some border is there. Let me show you how to see this. What is that? So once you get the images like this, so there is you need to do simple histogram equalization. That's all. Now what is this histogram equalization?
Sir,
Whenever we have image, so now this represents the 0, this represents the 55. Histogram is the distribution of the pixels. Like here 1, 2, 2, 2. So 1 will be coming one time, 2 is coming. Like here 1, 2, 3. So 2 pixel is coming 3 times. So histogram is just like a representation of the intensity values we are graphically showing. Now what equalization will do? Now if the too many images are on this side, too many pixels are on this side, that means it is a dark image. And if too many pixels are on the white side, that means it is a toward the white side. So we have to convert into equalization, so we can get the such kind of output. So let me show you this before proceeding This is important. If I see this code might be available here. Meanwhile, you take the advantage of these 2-3 minutes. You download the code, and let me search here if it's there. Okay, let me open another code. Let me open my offline Jupyter notebook, and simple how to read this image. Now, before proceeding further, let me show you. First, and also there are certain issues are there when you're doing some kind of project with Google Colab, that also I will discuss. So here I'm uploading the image. You can upload the image using there is a folder on the left side. I'm uploading this image, or with the code. You have both options. It's going to connecting. You can see here it's connecting. Once it will connect, you will get the menu over here.
Sir.
Let me upload and show you this.
Okay, sir.
Just it will take 2-3 minutes. You will get the idea. So meanwhile, all of you,
Thank you, sir.
Please download the code. Download the code from the Google Colab.
Sir,
Yeah.
sir, कहाँ से sir? Link तो नहीं है sir.
Yes. Let me show you here. Using histogram, you can also match the images.
Hello.
Hello.
Excuse me.
Yes. Yes. Yes.
Sir, should we, this code can we download after the session also, no?
Yes.
The
Yes.
classroom link be there, no?
Yes. Yes.
Okay.
Yes. So shall I show you the histogram equalization, or shall I proceed with this phase detection?
Sir, proceed with this phase.
Okay. So later on also, I will share the code here also about this. I will show you. I will announcement, and whatever your questions are there, which code are right now, because we have the constraint of time, we left with approximately 1 hour. I will share the code here. So just maybe today or tomorrow, I will share the code, whatever your doubts are there. So I have ample resources. You can see in my, I have a long repositories are there along with me. So it may take some time. Lot of OpenCV codes are there, but still, if you are interested for a particular problem or any question, please post your queries here, and we will be able to see. So I can see right now. Oh, I will share the code here. So I can see now around 2 students have joined, but other people can also join and they can ask the question. So here I will make, this is a concept of integral image that also I will show, and I will give here code for your queries. So you can ask your query and I will share the code. So for histogram equalization, I will put after this. Now let me proceed with it. Now the major issue is with the Jupyter notebook is that with the passage of time, the versions are changing. Earlier there was 3.10 version, then 3.11 version came. Now it's 3.12. Maybe after few months it may go to 3.14 or maybe some other versions. So what are the problems are there? The code that you are working right now with 3.10 or 3.10 may not work with 3.12. because of the internal changes of the libraries. So I will show you how to resolve those libraries. Suppose you are working with 3.10 or 3.11 and code is not working with the, if you run this code, are you able to see, or shall I zoom it? Let me run this code. Is it fine?
Sir, it is,
Can you see?
sir, it is obviously fine, sir.
Pardon?
Obviously, sir. Obviously, sir, I am watching your code.
Okay. Okay, you for 10-20 minutes, just
Sir,
be with me and try to understand the code, because already I've shared the code. So now you want to work with the old version. So what you need to go to the runtime, and then change the runtime type, and then you can change the code like here. If you are working with the, you can change 25, then say OK, and then say save. Then again, now you can see it is connecting, and it will take some few seconds. Now it's connecting. And the best way is that otherwise you can work with the offline one. You can create the virtual environment over there. It's better to, if you are doing some research work, PhD work, or some project, it's better to work with the offline and with your virtual environment. Under the virtual environment, you can,
sir,
yes, please.
sir, you are using the, sir, you are using electronic boards.
Yeah, my screen is touchable screen, so I'm using one digital pen here.
Okay, thank you, sir. Is the next?
Yes. So now it's connecting, and after that, now you can see on the right side, it's connecting. It's taking some time, and again, if you run here, you will see the old version of Python. So this is a one solution for your problems. Now you can see it is showing 3.11.13, and there are certain deep learning libraries which does not work with 3.12, which only works with 3.11 because of the version compatibility issue. So in this way you can change. So now I'm going with the latest version. Go to change runtime, and you can select the latest one. I'm using the now latest one, and say OK. And now I'm giving the save. Now it's connecting, and again it will take a few seconds, and when you run it again, you can see now it will show the latest version of the Python.
So can you
this is
repeat
one-
this step? Can you
Yes,
repeat the
please.
step, sir?
Yeah.
How to change the latest version? Can you
Yeah.
repeat?
Go to the runtime. By default, it is the latest version.
Okay.
And if you want to work with because when I will show you your how to develop your own custom image. For example, you want to, after this learning this session, you want to perform this experiment for your students. In your class, there may be 50 students or 60 students. You want to along with their photo, you want to capture their name, Mr. Shah, Mr. Mohan, Ram, like that. So how to develop that model? So that model basically by default use a TensorFlow 3.12 version. 3.12 version. And for this Python, not 3.12, it's a TensorFlow 2.12 version. And recently it might be 2.21 or 19 versions might be there. This is related to the TensorFlow Google library. And for this Python 3.11 is required. If you have the latest Python, it does not allow to install even the TensorFlow 2.12. So to resolve those issues, you just go to the runtime. You go to the change runtime type, where you will get the option GPU, TPU, and you select the version here. So now I've selected the latest one. Is it fine? Is it okay?
Yes. Yes.
Then
yes,
you
sir,
can.
fine.
Now all of you need not to write any code. Later on, or maybe whenever you get the time, you download this code, and the image is shared there with the ATAL TIT, today's date, computer vision, OpenCV, and try to run it here. If you have any doubt, question, query, you can post your query in the Google Classroom. So now you run any library in Python, there is a one where you can note down pypy.org. This is a repository where you will find now today you can find this figure. 76 lakh releases are there. These many files are there. After 2 months or 1 month, you will see the figure may be crossing 80 lakh. And you can select, you might be working with whatever project you might be working with blockchain. So just you simple write blockchain. You want to integrate your image blockchain with images or with video, whatever library. So many libraries are available now. So I don't know what are your area of interest or what are your research work. So like sir has asked for the dark image or the night vision camera and images. So just you write like here. So again, Tai Chi splatting, acquiring image, Pi day night camera, Python module 2, Pi camera, Python. So many libraries are available. You can search by topic. It's a self-explanatory. So what is the website name? pypy.org. So here I'm writing pypy.org. Now there is only one thumb rule. There is only one thumb rule. How to install any library is simple. This magic symbol to show this is the command. Pip install that library name. That's all. So whether you are working with the simple libraries or maybe within, then you can use built-ins with that library documentation. I'm skipping this. So you can go through CV2 documentation about everything is mentioned. To see the comprehensive list of methods, you can use the directory method. This is a universal, again, command. Suppose you are working with the blockchain. So simple, you write directory blockchain. So it will show all the methods are available under this. If you are working with pandas library, simple say pandas. Now you don't know how to read the SPSS files, or you might be aware of the Excel files. So you simple write pandas.read_CSV file. So when you write the directory pandas, it will show all the libraries. Let me show you this example, then we'll proceed further. To see the comprehensive list of any library related to image processing, these are the functions are there, feature direction, constants, everything. So now here simple, I'm writing here import pandas, and then you can give the short name as PP. Now generally we do PD, you can give any name, and after that simple write directory PP. Those who have worked with the pandas library or NumPy library, you can see all now these features are functions are available. You need not to remember any function. So you can see here, let me zoom it. So you can see read CSV, read Excel, read HTML, pickle, SAS, read_SPSS. If you are using some statistical package, you can get through all these things. Now here CV2.imshow has some issue with the constraint. So now we have two ways. We can use either the Google, we can say from Google.patches, import the function, import CV2_imshow. We can use that function, or we can have our own function to show the image. So now it's in this function, we are defining the function to show the image, show image. And here, if the shape is equal to 3, that means if it is a color image, convert this color, you can see color BGR to RGB format. And if it's a grayscale, then keep that as a grayscale. So now our function is ready, and Python version already I have shown you. Now directly we will proceed further. So how to load the cascade classifier? Now either we can download and upload the cascade classifier, or this is also inbuilt here because it is under the CV2 library. So to see that, you can simple click here, user local lib Python 3 distribution, because now we are Google Colab is on which operating system? It is running on the one Linux platform. So if you run here lsb underscore release -a, when you run here, you will find it is using the Linux version variant Ubuntu 22.4. That means if you know some commands of the Linux, you can get the better, you can take the more advantage of the environment. So here you can see,
Sir.
you can, yeah. So under Python
Sir,
3.1,
you are great.
pardon?
Sir, you are great. You are working on Linux.
Yeah, thank you.
Sir, you are great. You are working on Linux.
Yes, sir. So this is working on the Linux, sir. This collab is running on the Linux platform. It is running on Linux and it is using this version. So now in Python 3.CV2, it's an inbuilt. So as I've shown you, you can download from that link, GitHub or GitHub, or it is already available here, like eye, frontal face, full body, and these har cascade classifier files are already available. So simple, we can initialize in a variable. This is a variable now. When I run this, it is showing CV2 is not defined. That means I have not imported the CV2. Something is missing. So I need to import CV2. So installation is not sufficient. We need to import CV2. So here, yeah, I have imported the pandas, but I skip this line. So wherever you get the error, you go here. Now we have to call this CV2. So simple, we'll call the CV2 now. There will be no issue. So OpenCV now is in our environment. So now again, I am showing this file. So now how to call this cascade classifier? This is a variable. Now let me run here and show you in the notepad. Let me copy this code. What I have done here, we are loading the har cascade classifier. So when I will show you about the car cascade classifier or the traffic light, that is not inbuilt here. So we will see how to upload those har cascade classifier and apply. So now in this code, you can see this is a variable. You can give any appropriate variable name. CV2.cascade classifier, CV2.data har cascade. This is a path plus concatenate the frontal face default.xml. So what we have done here, we have defined the cascade classifier in the variable. So concept already I have discussed you. You can go through this concept, how it works. So it is already mentioned in the book. Now we need to upload the images. So there are two ways. So you can upload from here. That is the one way. Or you just simple run this file. So now when I will upload, you can upload the zip file also. So here, so many images are there. So now instead of that, what you can do, you can simply upload these all images in the zip format. So here I am now uploading this file, choosing the file, and under this, now what I am uploading, image dataset, or you can upload multiple images also. Now once you upload the zip format, you need to unzip also. So now this file is uploading. You can see the progress. You can see now it has uploaded up to 30%. Here you can see the progress. It is uploading. You have to wait for that time. And then you can unzip it. How to unzip it? So again, in the Python, there is a library, zip file. You give the path, extract to images, and with zip file, unzip to this folder. So now it is uploading. And in that way, you might having 100 of images. You can start working with hundreds of images instead of single image. So up to here, any doubt, question, query to any participant? Now it is uploaded the image dataset. You can see here. Now 100% it is uploaded. Which folder? Image dataset. Then you need to unzip it. Here also I have given the comment. You can, when you do the practice, you can upload the other single image or zip image. And then you can do the unzip it here. And then you can check the content using the Linux command. And when you write here, ls-l, so under these many images are there. So many images are now there. Now you want to display, let's say, few images. So now I want to display first 5 images. So this is the code, and we will run it over here. And when we run here, you can see Lena image is there, and group image is there, person 1, cute dog, and car images is there, car2.jpg. So now after that, we can start working here. Now how to read the image? cv2.imread. It is in which folder? Images, image dataset. And now let me show you about the, we will work with the Lena image. So I'm writing here lena.jpg, whatever the image. So here I'm taking lena.jpg. Extension is very important because here there are 2 images for Lena. One is in the JPG format, another is in the PNG format. So these are very important. Sometimes JPEG, JPG. So these are very important. You have to give them, and it is a case sensitive. So now I have read the Lena image. Now I want to show this. Now earlier I have done the practice on this image. Now I want to show you the Lena image. So you can see this is the original image, and it is in the grayscale. Now, and if I show you the PNG, so simple, I will change the extension PNG. We will change here, and now you can see the this is the original image, and then we can apply the convert the image into grayscale. Simple. Now we have converted into grayscale. We want to detect the face. Simple, and we can see how many faces are there. So it is showing the coordinate and the width and height. And then we can draw the rectangle over here, and we can display the image. So you can see face has been detected. And if we want to show the image on grayscale or on the colored image, then we can show on the color image. Is it clear? Because in your schedule it was already there, so a bit fast I have shown you. Now I'm going to change the image to group face. Which image? Which is already here. Okay, group.jpg. So what we need to do in our this thing, group.jpg, group.jpg. Simple, just you need to change the image, that's all. No change in other code, whether it's a single image, single person image, or a group of people. So this is the original image, and then we can convert the image into grayscale. So now it's going to convert, now it's into the grayscale, and then we can detect the faces. And here, when we run here, so now it's there are so many persons are there, and it's trying to detect the faces. So it has detected a few faces. You can see it has detected here, and then we can try to draw the rectangle over that. So again, in the rectangle, you can see these are the colors we have specified: BGR, green color, and then the width of the, and here we want to display. So because it's a grayscale, so let me show on the detected face on grayscale and as well on the color image. So some rectangles are there. Now let me draw on the colored image. So now we are trying. So you can see, you can notice here, it has detected okay, and it has ignored this one, then this person, then okay, then this person, then this person, again this person, and some false positive are also there. So we can see the accuracy is in between 80 to 90%. Now there is a big question, how to get the 100% accuracy. This is very important. So you can think over a minute and you can share how to get the 100% accuracy. Any idea? So for that, we need to use a deep learning model. So up to here, any doubt, question, query from any participant?
Yes, sir.
Okay. Now let me show you about some more on the,
Sir.
Yeah. So now let me show you about the, yes. Yes, please.
Can I ask you?
Yes, sir. Yes, sir.
Sir, what is confusion matrix?
Okay.
What is confusion matrix?
Yes, sir. So now let's say, let's take an example of COVID. We are all aware of the COVID. So in the COVID, there were two possibilities are there. Person is either positive or negative, right?
Sir,
So now
confusion
we have,
matrix.
yes,
Of
sir.
three dimension.
I'm coming.
3 dimension.
Yes, sir. I'm coming. I'm explaining, sir, confusion matrix only on this example. Confusion matrix. It's very important to get the performance matrices. So now we have the actual data. So let's say we have 100 students and we have the positive and negative. And here on the top, let me use blue color. And this is predicted by the machine. This is predicted by simple, we can say predicted by AI or machine learning or deep learning or by any model. This is the prediction, positive and negative. So now when we say prediction, this is a prediction, positive prediction, negative prediction. So the person is positive, but the prediction is positive. This is known as true positive. Person is positive, but machine is saying, no, it is not positive. So it is a false negative. When person is negative and machine is saying positive, it is known as false negative. When person is negative and machine is also showing negative, it is known as true negative. These are the error 1, error 2. So our objective is to minimize this. So from this, we can get the accuracy. From this confusion matrix accuracy, we can get the precision, we can get the recall, we can get the F1 score. So how to get the accuracy? So true positive plus true negative divided by all. That means true positive plus false negative plus false positive plus true negative. And what is precision? The prediction by the machine divided by true positive total prediction plus false positive. What is recall? So here, let me show you again in blue color. Recall is true positive predicted by the machine by the total truth. So total truth is true positive plus false negative. And what is F1 score? Because in competition like Kaggle or in paper, they ask for F1 score. This is a harmonic mean. We have arithmetic mean, we have harmonic mean, we have geometric mean. So F1 score is a harmonic mean of precision and recall. So then it becomes 2 into precision into recall divided by precision plus recall. So this is the confusion matrix, sir. So this is the confusion matrix.
Sir, one question.
Yes, please.
Sir, one question.
Yes, sir. Okay, no question.
Sir, it is a 95% confidence level.
Pardon? Yes, please.
% confidence level that the prediction is true at the 95% confidence level.
I will show you. I will practically. I will show you about the confidence level also. Let me give me some time. So now we are uploading. I will show you the confidence level also. It is there in my talk also. So now we want to have the signal sign. So now I have uploaded this image, and then after uploading, we want to show this image. So this is the image. Now we want to see whether this model will be able to recognize this or not. So it's optional to convert into grayscale, because this Cascade file can work with the colored image also. So we can now upload the Cascade classifier. So once you download the Cascade classifier, you need to upload also. So now in the Cascades, I have a car, I have the stop sign, and then I can upload. So that means the Cascade classifier only works with car, not with other. And similarly, stop sign will work with only with the stop sign, not with the others. So now it has been uploaded. It is mentioned here, car and stop sign XML file. Then we can load the Cascade classifier. We can detect the object. Same concept, and getting the number of how many it has detected, only one. Then highlight the detected object and then plot the image. So when we run, now it has detected the signal. Similarly, we can try with the car. We can upload the car images. So it is already there. This is a car. And on this car, now we have initialized the car.xml. And then we can detect the car in the image. And we can find out how many cars it has been detected. And we can draw the rectangle around the detected, and we can plot finally. So you can see it has not detected 100%. So for that 100%, we need to go for the deep learning models. So in deep learning, similarly, we can do for the eye detection. So now it is very important. Just you note down, or you can take the photo. We are going to implement MTCNN. This is a very good model for the face detection. So it finds the faces in the image, refine the location of the detected, and identify the key points. So how it works? It works on the cascade convolution neural networks. It what it do basically. It detects the 5 facial expressions. What are those 5? Left eye, right eye, nose, and now on the mouth, left mouth corner and right corner. So what are those 5? Eye, left eye, right eye, nose, the left mouth corner and right mouth corner. So because of this, it is achieving 100% accuracy. So these are the advantages. So now what to do? First, we need to install this MTCNN. So now I'm installing, and pip install MTCNN, and all others are optional. And then we can again upload the image. So I'm uploading the same image. It is already there. What was the image name? Group. So face group. So I am now using this. Import the image, load the image. You can replace with your own image, and simple one-line code. Detector is equal to initialize the variable MTCNN, and using detector.detect face, and whatever the image and number of detected, how many it has detected, it will show here. So it has detected 15 face for this group, and we got this output. And if we want to do with the earlier one, simple, we will change the name. So the name was, so it will work only with the face, this model. So now after that, we required one model which can work with face also, object also. For that, there is a YOLO model. You only look once. YOLO model. So we will, after this, we will work with the YOLO model. So now what is the image name here? The image name is, we can see here, because it was in the, we can upload either separately or simple from here. Yeah, group.jpg. So simple we can say here, or we can copy the complete path, copy, and give it to the MTCNN. So it's a working code. You go line by line, don't skip any line. And then now what I'm going to do, simple changing the image. See, you need not to change anything. Suppose you have your own image. So simple, you need to change the image like this. So now I'm giving the group.jpg and we will run here. Now after running, it will show here how many persons are there in the image and how much it has detected. So simple code. So now it's running and you can see it is in the progress. So from MTCNN, we have imported this. This is a very best MTCNN, one of the best face recognition deep learning model. It is known as multitask cascading convolution neural network deep learning based face detection algorithm that can detect face and their key landmarks in image as well in the video also. So like in your case, you have the night vision camera, you want to see the face, it will detect the face. So now we got the output. So it has detected exact the number of persons. So it has detected 68 faces. You can see here 68 faces. So there are 68 persons are there. And now you can see it has detected almost everyone. You can see almost this person also with cap and also in between this person also almost. So you can see the accuracy is almost 100% with this deep learning model. So now you want to use some more print this, you can try. I'm skipping using this PyFiglet libraries. You want to use art library, you can use the art, you can print like this. Now we are moving toward the YOLO model. So for YOLO, we need to install Ultralix, and then we can read the YOLO light version, nano version. It is means YOLO version 8 nano. So easily we can deploy. This is the nano version. We can deploy with the if you have some IoT devices or lightweight and end devices. So on end devices, you can use easily this YOLO version. You can deploy, and now you can read. So now we have, I'm going to demonstrate two YOLO models, YOLO version 8 and YOLO version 2. So I have captured those two versions in model 1 and another in model 2. Then we can upload the image like here. Let me show you about the group image. So let's say we can upload any image here. Okay, let's say this image face. So in your case, just you need to change the image. Now it has been uploaded. We can read the image, and now we can see the result. So what it is showing, you can see 16 persons are there. 16 persons are there. And when we run the another model, so it is showing again 16 persons. So both are doing 100% accuracy here. So what is the advantage of this YOLO model? Now you can see these are the persons here. Similarly with the model 2, we can save also. I am right. If you want to publish paper, we can write and we can download the result from here. We can click and you can download and you can publish on your journals or your reports. And then you can plot the image and you can see the person. Now I want to change with some object, not faces, but let's say I want to change here with the, let's say, car only with the same this one. So let's say car 2. So now what we need to change here, we need to change because we have directly uploaded. So simple will say here car2.jpg, car2.jpg, and now we can see the results with model 1. So it's showing 21 cars, you can see. So that means YOLO model can work with face also, and it can work with any kind of object. You can try with animals, birds, or any objects. So it is showing 2 buses, 1 truck, 21 cars. And similarly, we can see what the car 2. So it is showing 16 car, 1 bus, 2 trucks. So we can annotate, we can plot, and now you can see. So it has find the truck, bus, and so many cars. And with the other model, the accuracy is not up to 100% because it has skipped some portion here. But to some extent, it is good. Now, another thing you want to do with your own data set, with your own students, with your own data set. So how you can do? You can use a teachable machine with google.com. I believe you have already this demo on this. You directly go to
Excuse me, sir.
Yes, please.
Sir, one question be there. Sir, as
Yes.
this image shows multiple persons with
Yes.
label, person
Yes.
0.61, person
Right.
0.91. What is
That
the
is the
value of
confidence.
this?
That is the confidence level.
Okay, okay,
Confidence level.
okay. Thank you, sir.
Yeah. Now I am going to show you one image, and now which TensorFlow we are using 2.19. And if you are using 3.11 Python, then you can use TensorFlow 12.12, but it will not work because when you try to install TensorFlow 2.12 or 13 or 14 or 15, it will not allow you because Python 3.12 does not allow the TensorFlow below 2.16. So now how to deal with this? So for that, we have import the TensorFlow. We are using the TensorFlow library. Now we have import the required libraries, and it's optional to disable the scientific notation for clarification. Now we can upload these model. These are the weights. Now I have trained the model with the teachable machine. I am uploading these two. So Keras model and labels. So now I am uploading here, and we can select here. So there you can see under the final lecture, there is a one own model, and under that there is a converted Keras. Now I'm uploading these two. And now how to develop these two model, I will show you after this demonstration. So if you are working with the 3.11, you can use the TensorFlow 2.12. Now you can save the Keras and you can save the label. Now, if you are working the old version, this will work. But with the Keras version 2.19, it will give you the error. What is that error? Unrecognized depth-wise convolution 2D. So how to resolve in 2.19? So this is the solution. So what is the solution here? We are disabling the depth here. We are disabling the depth, and this is the model summary. So when we run here, this is the model. It's based on MobileNet model, and then we can read the labels. We can print the labels. I have trained this model on aeroplane, drone, animal, car, flower, tree. We can go to the Google, we can download some images, and we can prepare the array to feed the model. And now I'm going to upload some image. So now this is the image I'm going to test. So under the final, I have here one image, let's say this one. I'm going to test what is this image. So I'm uploading this image. So now all of us easily we can identify this is a drone, but how machine will recognize? So we will upload this image. So under here, I have uploaded the image D3. You can give any name, and then we are going to convert into RGB, because in deep learning model you run with any library, it has a predefined size. So like here, the size is 224 by 224. We are converting the image to the NumPy. We are normalizing the image. We are printing the normalized image to show you. So because the intensity values are in between 0 to 255, computation will be too complex. To reduce the computation, we are normalizing. So the values will be in between -1 to 1. Then we are loading the normalized image, and now we are going to make the prediction. So we can simply say model1.predict data, and we get the np.argmax. What is this? So this is a function of NumPy. Suppose here I have some predictions. Let's say I have 5 objects, and the predictions will be in the form of probabilities. So let's say probability 70, 90, 80, then 60 and 50. So in Python, there are 2 types of indexing are there. One is in the forward direction. It starts from 0, 1, 2, 3. And one is in the backward direction. That starts in -1, -2, -3. So here easily we can find out which is the highest probability here, 90. And what is the index of this? 1. Because index starts from 0, 1, 2, 3, 4. So argmax will give the maximum index of that which has the highest probability. So we will get the index. So in this case, we'll get the index 1. And suppose there are another probability with the 90, so it will identify the earliest one, 90. So argmax will give the index of that value which is highest in the this array. So now we are going to predict the class name and the confidence, and then we are going to display the prediction. So final prediction is now sir has asked the question. We got the confidence score and the drone. So how I have developed this? So we will go to the teachable machine, click on the get started, and now there we can do the audio also. Now we want to see whether what type of bird is there, whether it's peacock or some other. We can put their sample and give the label, or we can read the pose and we can do the image project. So it is best for model, and the requirement is 224 by 224. Automatically the code will do that one. You can capture the image or you can upload the image. You can choose the image from your files. So let's say randomly I'm just giving students, or like here, just to show you. You can train 1, 2, and you can give the label here. Similarly, you can upload the images of your students and you give the name here of one student with multiple pose, or you can capture with webcam. So here I'm giving group photo. Now for next, I'm giving the label here. Let's say fruits. So now we need to upload the fruits. We can upload, choose the images. So you must have that data. So that is under the under image dataset, or under the own model. There is a dataset of objects are there. I have used these images. So let's say drone. So you can select randomly some images, and then you can give the name here, drone. And you want to have some more classes, then add a class. So I just I'm interested only in these 2. So I'm say unknown, and I can upload randomly any images. Upload the images. So let's say so it's very easy, and you need not to do any coding. Code is required in this case. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's say I have selected here these images. So let's This is the first step. Then you click on the train model. And then you click on the export model. So now it's training. So now it has trained the model. And then you click on the export model. And when you click on the export model, you have to click on the TensorFlow. Click on the TensorFlow. And this is the code that I've shown you. This is the code, simple you copy paste. If you are working with the TensorFlow library 2.12, this code will work. If you are working with other TensorFlow library, you need to just change that code already I have shared. So you just need to open your image here, and this is the code, and then you can download. You can click here, download my model, and in this way, now it's converting, and you will get the code. So now it will take a few more seconds, and you will get the two things in that model. One is this model in the form of H5, that is the weight of the model. Another are the labels. Because now it's running on the cloud, so that's why it's taking some time. Now it has been downloaded. So now if I show you here, show more option, 7-zip, extract to this folder. And when you see, this is the model and these are the labels. Group, drone, unknown. Suppose you want to change to students. So you need not to again recompile or rechange anything, just simple save it here, that's all. And after that you upload here the model, the image name that you are interested, and this is the image name here, like here image open, and this is the model here. So now I stop here. We can take some question and query. So again in the presentation, when you refer it later on, so you can see the deep learning is a part of AI. Instead of using the handcrafted learning feature, you can use the kind of CNN, which is having the convolution layer, pooling layer, deep layer. Input image is fed into the convolution neural network, extract the low level feature, then deeper layer combine the shape, and finally classify the object. So detection objects are there, YOLO, SSD, RCNN. And why deep learning works well? Because it learns features automatically. This is the most important. So we need not to do the manual feature engineering, and it improves the performance. So already we have seen with the large data set and real world applications, so many real world applications are there, like in agriculture, medical imaging, surveillance. And it's just like teaching a child to recognize face. And by showing thousands of face and known face example, child learns the pattern automatically. Similarly, deep learning learn the patterns automatically. The core thing is they are working on the patterns, and they can recognize any face. And if we compare with the deep learning and HAR cascade, so both have their own pros and cons. So deep learning works for complex and multi-object scenes, and high computation is required. So if you later on, if you are interested more in this, so these are the deep learning architectures are available: feed forward networks, convolution neural networks, recurrent neural networks, and where we can apply autoencoder, GANs, transformer. Already we are using now on ChatGPT, BERT, and transformer, graph neural networks, capsule networks, diffusion models, hybrid model. And these are the summary, and these are the links. You can refer it later on. So now I stop here. What we have done today. So we started with the traditional way, how we can work with the traditional way, what are their limitations, and then why we require the deep learning and why we should go for this. Okay, now we can take some question query, then we'll bind up the session. So
Hello,
here,
sir.
yes, please.
Sir, in this teachable machine, as I upload my pictures, then in the export model under this, there is movement in the picture, and class 1 and class 2 shows difference. either 40%, 60%. What is that, sir? Is
Okay,
it matching the image or?
Okay, so I'm taking your question like this. So you have uploaded the only two images.
Yes, sir. In two class 1 and class 2, I have
So
taken
let's
3
say
images.
this is class 1. How many images you have uploaded?
In class 1, I have taken 2 images.
Okay, in second class?
Only 1 image.
No, minimum 2 is required basically.
Minimum 2. Okay.
Minimum 2 are required, otherwise it will not capture, because how it will differentiate. So in
Okay.
deep learning, because it is a deep learning based, it is has insufficient data.
Okay.
It has insufficient data. So if
Okay.
so, what you can do, you click on the mouse and keep on
Yes, yes.
pressing the, yeah, it will
Yes, sir.
capture from your
Yes,
webcam.
sir. I done. On
Webcam.
clicking the webcam
Yeah.
and holding that,
Yeah.
I will get the poses.
So
That's
when we
good.
have when we have less data and when we have insufficient data, deep learning will not work. We
Okay.
cannot say for every problem deep learning will work, for every problem machine learning will work. No. So for that kind, we need to go for the
Right.
feature engineering or hard cascade classifier. So
Okay.
that was the issue in your case.
Okay. Okay. Thank you, sir.
Hello, sir.
Yes, please.
Hello, sir. Sir, what is the type 1 and type 2 errors?
Okay, you want to know more about that?
Yes, sir.
You want to know? Okay. Suppose we have some image recognition, this one. Let's say for army persons. Let's say for army persons. This is our camera. This is our camera. And let's say one army person is coming. Army person, and this is non-army. So what happened now? Camera is saying, don't allow him. Don't allow him. So now what is the issue? It's an error. Agree?
Yes, sir.
It's an error. Now what type of error is there? Person is positive,
Type 1.
but camera is saying negative. So we need to refer this positive, negative, positive, negative. So here, so a person is positive. That means it's a genuine person. But our machine learning is saying no. So it is a false negative. Is it clear? So this is the error.
Sir, it is a two-dimensional matrix.
No, because we are taking, when we are talking about the how many classes we want to find. Two class identification or multi-class. Multi-class means there could be 3 classes, there may be 4 classes. Prediction. 4 class prediction. For example, the person is, let me show you, let me explain you. When we want to find whether person is having diabetes or not. So when we are going to prediction, yes or no, so it is only 2 variables are there. So we can say it is a binary classification problem. Now, if you take the example of iris flower, so there are 3 kind of flowers are there. So it's a 3 class. So there will be, just to simplify, so it will show flower 1, flower 2, flower 3. Again here, flower 1, flower 2. Then depend on the how many predictions are there. Multi-class. So it can be 2 for just for your understanding, but it can be 3, 4. It depends on what type of predictions you want to perform. Is it clear? So now take the second case. Person is negative,
Yes,
but it's showing allow him.
Yes, sir.
So again, it is a negative. But yes, please. Yes. Person is negative, but it's showing positive. So again, it is a false positive. So this is the errors. Is it clear? What is false negative, false positive? So our main objective is to minimize these.
Sir, it is clear.
Okay, thank you. Thank you.
Sir, in case of three variables, how
Yes, sir.
to construct a confusion matrix?
Okay, let me show you. So let's take an example of flower. So here I am taking flower 1, flower 2, flower 3. Similar prediction is a flower 1, flower 2, flower 3. So here
Yes,
when
sir.
we say about that diagonal,
That was
here in
1
the,
1 1.
so flower 1, it is showing flower 1 is a positive. Flower 2 is a positive. Flower 3, flower
Yes, sir.
3.
Diagonal matrix is 1 1 1.
Yeah. Whatever the values we are getting here, those are kind of false negative, but that depend on here. Now how to find, now in this case, again, it will convert into 2 matrix.
Okay, sir.
2 matrix, it will. So with consent of F1, we have to find the 2 class. Again with the here 2 class. Again with the here F2 class. So whether it's positive, negative, positive, negative, positive, negative. So now we have to find here true, positive, true, negative. So it's F1 and it's F1. So it is a true positive. So when we implement, we may get some value here because there may be 100 samples, maybe there 30 are showing true positive for this. And then it is showing true positive, but the prediction is showing a true negative. So here it's a F1 and here
Yes,
it's
sir.
F1, it's a true positive. It's a F1 and prediction is F2. So again, it is we need to do here for understanding true positive, true negative, false positive, false negative. So in that case, it's a positive basically, and it shows no.
Sir, are you writing anything in the screen? It's not visible, I think.
Any participant is able to see the what I am writing?
No,
sir,
no, sir.
No, sir.
No.
Cannot see anything.
Okay.
Only
Now
the
can you see?
student drone
Now
and
can you see?
unknown screen is coming.
Okay, can you see now?
No, sir. I think you need to stop screen sharing and again need to start the screen sharing.
Oh. Now, can you see now?
No, sir.
Okay. Let me stop again. Let me start again. So I will later on, I will put this example with example in the Google Classroom. You can refer that.
Okay, sir.
The multi-class. So now can you see now here? Can you see now?
Yes, sir.
Yes, sir.
Now it is coming.
So shall I show you first this confusion matrix of 2 elements or with 3 class?
3 class because already time is over. So
Okay.
3 class.
So here flower 1, flower 2, flower 3. So what is there? We need to flower 1 is always true positive. Flower 2 is a true positive. It's a true positive. So individually we have to calculate. So I have 2 slide example I will upload there and then I will share with this. So similarly, you need to now convert into 2 class here. So I will share that example and then that will be more clear to you. So what we have done today, we have seen about the traditional method, manual method, but it has the limitations. And how to resolve those limitations, we need to work on the deep learning model. There we have seen about the MTCNN, YOLO model, and the TensorFlow. So even though you are new for this field, you directly work with the no class code, that is a teachable machine. Just you code already have shared. You train with your model, with your students' face, capture their face, train the model, download the model, upload. Just you need to make 3 changes there in the code. What are those 3 changes? If you see about the teachable machine, you need not to worry, you need not to change anything. Just you need to upload Keras model and you need to take care because by default it is in the uppercase M, only M. So that you need to rename. How to do the rename? You rename on your machine and upload. And that is only one thing. And second, change labels will be same like labels. And third will be on an image that you are going to test. That's all. So you can test here. That's all. So in summary, now you can work with the 4-phase MTCNN or with the that we have done with the manual work or cascade. You can work with YOLO, and still you are not comfortable with coding or you don't, then you can go for the teachable machine. So these 4 portions we have seen today. Still, if you have any question, doubt, sir, can you see what I am writing here?
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
So you can put in the Google Classroom anytime, and we will in touch with that Google Classroom. I will upload here.
Okay,
So
sir.
with these words, I thank one and all for your kind attention. Thank you.
Sir,
Thank you, sir.
Yes, please.
sir, I have a simple question.
Yes.
If my model is CNN sequential, if now I
Right.
want to train my model.
Right.
For train the model, how to upload and how to train this data. So what will
Okay.
be the code?
You want to do your own customize, right?
Yes, sir.
So you will define some layer. First, you should go to the runtime, change the runtime to GPU. Otherwise, it will take a lot of time.
GPU. Yes, sir.
You select this GPU. This is the first thing. Then you define the model. I have also some customized model. You train those model, and after training the model, you can export in .h5 format. You need to convert into, there is only one line code is there. I will share later on, or you post the question, or you can, I will share. There is a one option, TensorFlow.
I have to put questions, sir.
On Google Classroom, you can put. You can,
okay, sir.
or otherwise, I will write down my email here.
Okay, sir.
Yes, sir. That would be feasible.
Yeah. So you can write here FDP7 at NITTRCHD.ac.in.
Sir, excuse me, sir.
Yes.
Okay, sir. Thank you.
Otherwise, here, when you join the Google Classroom, you can directly put the question here. And simple, you can write here, stream, and automatically it will come to us.
Okay, sir. Sir, one question be there.
Yes.
Sir, this T4 GPU is the type of GPU? T4?
Yeah. This is a
T4 stands for, sir?
It's a GPU, because again in GPU so many categories are there. So they give for 11 hours, or earlier it was 11 hours. So that is sufficient for our research work.
Okay.
If you go here, I can show you here. Simply you select GPU. So it will disconnect and change to the GPU now. And select, okay, that's all, very simple.
Okay.
So you can start by default. If you are not working with GPU kind of application, then work with CPU only.
Okay.
Otherwise, what will happen if you select the GPU, because it's a resource intensive. So Google, when say it's idle, they will disconnect your sessions.
Okay.
So once your code is ready, you can use the GPU. So let's say you have developed your own model. So if it's taking 4 hours on CPU, it will take only 5 to 10 minutes on GPU.
Right, sir. Okay, sir. Thank you, sir.
And some of our PhD scholars, what they have done, when they reach to the last stage, they purchased for 1 month this thing for their completion of this.
So generally, what will be the cost, sir, for 1 month?
I think 400 or 500 rupees, something they have mentioned. I never purchased, but our scholar has mentioned, because he was working on the medical data and huge data that was there.
Okay.
So 400 or 500 rupees he was mentioning for 1 month.
Okay, sir. Thank you so much.
Right.
Thank you, sir. It was very nice session, sir.
Thank you.
Thank you
Sir,
so much.
this will be uploaded on YouTube too, no?
Yes,
I don't know. But
the recording video will be uploaded in the YouTube.
Okay, thank you so much.
Thank you, sir, for your excellent
Thank you.
deliberation.
Thank you.
So thank you. So with this, we conclude the session 8, and again tomorrow we will meet at 6 p.m. So thank you all. So now we conclude the session here. Thank you, sir.
Thank you.
Thank you. Thank you, sir.